Okay, so example 9 for 5.3 self-inductance. A 500 turns of the solenoid of 8 cm long when the current in the solenoid is increased from 0 to 2.5 ampere in 0.35 second. The induced EMF is 0.012 volt. Jadi awak tahu dekat sini, kalau mengalami increasing of current, okay, so increasing of current, maka to oppose this increasing of current, induced EMF akan negatif. Yang tu kamu kena tahu So negatif maksudnya negatif 0.012 volt. Okay, sebab dia berlaku increasing of current. To oppose this increasing of current, induced EMF kena negatif. Okay, so inductance of the coil. Sorry. Inductance of the solenoid. Okay, inductance of the solenoid. So you nak kira inductance of the solenoid. Induced EMF is equal to negative L di per dt. So negative L, jadi you tahu change of current I final tolak initial kan, 2.5 minus with 0 lah, and then 0.35 time. Okay, so induce ni kena letak negative 0.012. So L negatif dan negatif akan cancel off. So L akan jadi 1.68 times 10 to the power of negative 3 Henry. Okay, good. So next adalah cross sectional area of the solenoid. Cross sectional area of the solenoid. Jadi nak cari area. Jadi tak ada cara lain melainkan daripada formula basic dia itulah, L is equal to mu naught N power of 2 A over L. Sebab dia adalah solenoid, jadi kita guna over L lah. Kalau coil over 2R. Okay, so L is 1.68 times 10 to the power of negative 3. Okay, mu naught is 4 pi times 10 to the power of negative 7. Number of turns tadi 500 kan? Alright, 500 turns, and then A nak cari, divided by length of the solenoid. Length of solenoid is 8 times 10 to the power of negative 2 meter. Okay, finally we get area is equal to, okay, area is equal to 4.28 times 10 to the power of negative 4 meter square. Okay, boleh Alright, next adalah final magnetic flux linkage through the solenoid. Final magnetic flux linkage final is equal to Li final. Okay, so L adalah 1.68 times 10 to the power of negative 3 tadi tu, times dengan current final dia adalah 2.5. Okay, so kita akan dapatlah 4.2 times 10 to the power of negative 3 Weber. Okay, alright. Okay, 5.4 energy stored in an inductor. So example 10, we have a solenoid of length 25 cm with an air core consists of 100 turns and diameter of 2.7 cm. Calculate the self-inductance of the solenoid and the energy stored in the solenoid. So self-inductance in the solenoid, you can use the formula for solenoid. So for A, L is equal to mu naught N power of 2A over L. Okay, so because they give you diameter, so determine area by using diameter formula is pi d squared over 4. So pi d is 2.7 times 10 to the power of negative 2 power of 2 divided by 4. So area we get here is 5.73 times 10 to the power of negative 4 meter square. Okay, so substitute the value in this formula. So mu naught is 4 pi times 10 to the power of negative 7, N is 100 turns, power of 2, area is 5.73. Okay, 5.73 times 10 to the power of negative 4, and then divided by length. Length is 25 cm. 25 times 10 to the power of negative 2. Semua kena tukar SI unit tau. Okay, jadi awak akan dapat 2.88 times 10 to the power of negative 5 Henry. Okay, so next B, they ask you to calculate the energy stored. Energy stored in the solenoid. So energy stored in the solenoid is U is equal to half Li kuasa 2. Okay, so half L is 2.88 times 10 to the power of negative 5 times with I is 1.6 ampere. Dibagi tadi 1.6 power of 2 Okay, so we get 3.69 times 10 to the power of negative 5 joule. Okay.